You have been trained to believe in the line. From the moment you first threw a ball or watched a car drive down a highway, your brain constructed a model of motion based on continuity. You imagine an object leaving point A, traveling through a continuous sequence of intermediate points, and arriving at point B. You visualize a trajectory. This intuition is reinforced by every physics class you took in high school. You learned that if you know the initial position of a particle and you know its velocity, you can predict its future with absolute certainty. You draw a parabola on a graph. You calculate the time of flight. It feels neat. It feels deterministic. It implies that the universe is a machine, and if we just look close enough, we can see the gears turning. But this model is a hallucination. The smooth arcs and straight lines you see in the macroscopic world are not fundamental features of reality. They are statistical lies. They are approximations that only work because the objects you interact with, baseballs, planets, grains of sand, are composed of trillions of atoms. You are not seeing the behavior of matter. You are seeing the average behavior of a mob. When we strip away the mob and look at a single player, a single electron, the concept of trajectory does not just become blurry. It ceases to exist. If you fire an electron from a source toward a detector, you instinctively assume it must traverse the space between them. You assume that at any given microsecond during its flight, the electron is somewhere. It has coordinates. It has a specific location. Even if you aren't looking at it, this is wrong. Between the moment the electron leaves the source and the moment it hits the detector, there is no path. There is no line. The electron does not travel in the way you understand traveling. It does not exist at a specific point in space in the time between emission and detection. To ask where is the electron right now, while it is in transit, is a meaningless question. It is a category error. It is like asking what is the flavor of the number 7. The universe does not hold that information. This is difficult to accept because it violates your sense of object permanence. You assume that things exist continuously, but in the quantum realm, the electron is not a hard marble rolling through space. It is a ghost that only manifests as a particle when it is forced to stop. The trajectory you imagine is something you project onto the system, not something the system possesses. The electron starts at A, it is detected at B. But what happens in the middle is not a straight line. It is a terrifying silence where the rules of logic simply do not apply. If the electron has no trajectory, then we must confront the physical manifestation of its absence. We do this through the double-slit experiment, a setup so simple it should be mundane, yet so devastating it haunted Richard Feynman for his entire life. Imagine a barrier with two thin parallel openings. Behind it, a screen capable of recording the impact of a single particle. We fire electrons at this barrier, one at a time, not a stream, not a beam, one solitary electron, every 10 seconds. If your intuition of the marble were correct, the result would be predictable. Each electron would pass through either the left slit or the right slit. Over time, you would see two distinct piles of impacts on the back screen, directly behind the openings. This is how bullets behave. This is how sand behaves. To resolve the tension of the impossible pattern, we decide to do the most logical thing a scientist can do. We set up a detector, a simple light source or a sensitive probe right next to the slits. We want to catch the electron in the act. We want to see, once and for all, which hole this marble actually passes through. We are looking for a definitive left or a definitive right to restore our sanity. And the moment we turn the detector on, the universe changes its behavior. As soon as we are able to determine which path the electron takes, the interference pattern vanishes. The stripes disappear. The wave of probability collapses into a dull, predictable spray of particles. The electrons begin hitting the back screen into simple piles, exactly like the bullets or the sand we previously dismissed. The electron has stopped interfering with itself. It has stopped exploring multiple histories. It has become the thing you wanted it to be. The terrifying realization here is that the electron knows it is being watched. But knowing is too human a term. It implies consciousness or intent. In reality, the situation is much colder. The act of measurement has stripped the electron of its ambiguity. You might think this is a mechanical failure. You might argue that our detector is poking the electron, like a clumsy giant trying to feel a butterfly with a sledgehammer. You might think that the physical interaction, the photon bouncing off the electron, is what knocks it off course. This is a common intuition. And it is wrong. It is not the bump that destroys the wave. It is the information. If you could design a detector that was so gentle it didn't transfer a single joule of energy to the electron, yet it still allowed you to know which path the electron took, the result would be the same. The interference pattern would still die. Diagram showing information equals particle versus no information equals wave. The universe seems to have a built-in censorship mechanism. It allows a particle to exist in a state of multiple, contradictory possibilities only as long as those possibilities remain secret. The moment to which path information is available to the rest of the world, the ambiguity is resolved. The ghost is forced to materialize. We are forced to confront a conclusion that destroys our classical sense of objectivity. The properties of a system are not independent of the act of observation. You cannot talk about what the electron is doing when you are looking, because the very act of looking defines what the electron can do. You are no longer an observer. You are an editor. But that is not what happens. As the impacts accumulate over hours, a pattern begins to emerge from the darkness. It isn't two piles. It is a series of stripes. Bright bands of high impact separated by dark bands of zero impact. This is an interference pattern. In any other context, this is the signature of a wave. When two waves overlap, they reinforce each other in some places and cancel each other out in others. But waves are collective phenomena. They are spread out. We are firing electrons one by one. This forces you into a logical corner that has no comfortable exit. If an electron produces an interference pattern, it must be interfering with something, but there is no other electron to bump into. The only thing left for the electron to interfere with is itself. To produce this pattern, the single electron must, in some sense, pass through the left slit, and it must pass through the right slit, and it must pass through neither, and it must pass through both. It must explore every possible trajectory simultaneously. You want to say this is impossible. You want to say that the electron is really a particle and we are just seeing some strange wave-like trick, but the screen doesn't lie. If you fired a bullet through a door, you would never expect it to land in a position that suggests it traveled through two doors at once and hit itself on the way. Yet, at the fundamental level, this is exactly what matter does. The electron refuses to be a thing located in a place. It exists as a wave of probability, a mathematical smudge across space that only considers the slits as suggestions rather than boundaries. It does not choose a path because, at this stage, the universe has not asked it to. It is only when we try to outsmart the electron, when we try to watch it, that the horror truly begins. In the mid-20th century, Richard Feynman looked at this mess as flickering between wave and particle and decided that the problem wasn't the electron. The problem was our math. We were trying to force the electron to choose a path. Feynman suggested something far more radical. The electron doesn't choose a path. It takes every path. This is the path integral formulation, or the sum over histories. To understand how an electron gets from the source to the detector, you cannot just look at the straight line. You must calculate the path that goes through the left slit, the path that goes through the right slit, the path that zips up to the moon, loops around, and comes back, the path that zigzags through the room in a chaotic scribble. You think this sounds like a mathematical joke. It isn't. Feynman's insight was that each of these infinite paths has a phase. Think of it like a little arrow spinning like the hand of a clock. For most of the wild, nonsensical paths, these arrows point in opposite directions and cancel each other out. They are destructive. They vanish into a mathematical zero. But near the classical path, the straight line, your intuition loves the arrows align. They add up. They reinforce one another. Animation of many spinning arrows canceling out, while those near the center line point the same way and grow in the double-slit experiment. The electron doesn't choose a slit. The wave of the electron ripples through both simultaneously because both paths are mathematically open. They are both part of the sum. When they meet on the other side, their phases either combine to create a bright stripe or cancel to create a dark one. This destroys the idea of a single reality. We perceive a single straight trajectory for a baseball because the wild paths for a trillion atoms cancel out so perfectly that only the average remains. The straight line is just the most probable history of a massive object. But for the electron, the wild paths are still significant. The electron is literally a sum of every possible thing it could be doing. Feynman was right because he stopped trying to visualize the electron as a thing moving through space. Instead, he treated it as a set of possibilities interacting with each other. The universe isn't a collection of objects, it's a collection of overlapping histories. If you find this confusing, you are in good company. Feynman famously said, "I think I can safely say that nobody understands quantum mechanics." He didn't mean the math was too hard. He meant the reality the math describes is fundamentally incompatible with the way a human brain is wired to perceive the world. The electron is not lost. It is simply everywhere it is allowed to be. If you are still holding on to the idea that the watcher physically disturbs the electron, that this is a matter of a photon bumping a marble, this is the moment that intuition must die. Enter the quantum eraser. Imagine the same experiment, but with a twist. We place a detector at the slits, so we now have which path information. As we saw before, the interference pattern vanishes. The electron behaves like a particle, but we add a second stage. Before the data reaches our eyes, before any human observes the result, we pass that which path information through a device that scrambles it. We erase the knowledge of which slit the electron took. If the physical bump of the detector was what destroyed the wave, the pattern should stay dead. The damage is already done. The electron was poked. It should remain a particle, but it doesn't. When we erase the information, the interference pattern reappears on the screen. The electron returns to being a wave, despite the fact that it was already detected at the slits. It is as if the universe is constantly checking its books. If the information about the path exists anywhere in the environment, reality is a particle. If that information is destroyed even after the electron has already passed the slits, reality reverts to a wave. This suggests something deeply unsettling about the nature of time and causality. In some variations of this experiment, called delayed choice, we can choose to erase the information after the electron has already hit the back screen. The results don't change. The electron's past behavior seems to depend on what we do with the information in the future. We are forced to accept that the electron is not a physical object in the way we understand it. It is an informational entity. Reality is not made of stuff. It is made of facts. If the universe can know a fact about a particle's position, it must grant that particle a position. If that fact is hidden or destroyed, the particle is free to be a ghost again. The strange thing that happens when you watch an electron isn't that you are changing its path. It's that you are forcing the universe to commit to a story. When you don't watch, the universe remains uncommitted, a sea of infinite, overlapping maybe, at this point. It is tempting to retreat into mysticism. You might be tempted to believe that your mind has a special, magical power over matter, that the universe requires a human soul to look at it before it can decide what to be. This is a seductive idea. It is also a misunderstanding. The watcher does not have to be a person. It does not have to be alive. It doesn't even have to be a machine. In the language of modern physics, the transition from wave to particle is caused by a process called decoherence. Measurement is not an act of looking. It is an act of entanglement. When an electron, which is a clean, isolated wave of probability, interacts with anything else, it shares its information. If a single photon bounces off that electron, or if the electron bumps into a stray molecule of air, that information leaks out into the environment. The environment records the electron's position. The which path information is now written into the state of the surrounding universe. Once that happens, the electrons' different histories can no longer interfere with each other. They become decoherent. They lose their connection. The reason you don't see the people around you flickering like ghosts or passing through two doors at once is not because someone is watching them. It's because they are constantly being watched by the air, by the light, and by the ground. A human being is too large and too noisy to remain a wave. You are being measured by the universe every trillionth of a second. This is why quantum effects are so hard to see. They require perfect isolation. They require a silence so profound that not a single bit of information escapes the system. The moment the system talks to the outside world, the overlapping histories vanish, leaving only the one history we call reality. The collapse of the wave function is simply the universe becoming consistent with itself. It isn't that your mind creates reality, it's that reality is the result of everything interacting with everything else. We are not the masters of the quantum world. We are just another part of the noise that forces it to stay still. Chapter 7. The only mystery are left standing where Richard Feynman stood decades ago. Looking at a single electron and realizing that everything we thought we knew about being is a thin veneer. You think you are living in a world of objects. You think the chair you sit on, the screen you hold, and the body you inhabit are solid, persistent facts. But as we have seen, the closer you look, the more the solid world dissolves into a haze of possibilities. The electron is the ultimate witness to this truth. It is not a thing. It is a behavior. It is a set of relationships. It reminds us that the universe is not a collection of independent parts, but an interconnected web of information. Feynman called this the only mystery because if you can truly grasp the double-slit experiment, if you can sit with the discomfort of the wave and the particle, you have grasped the core of everything. There is no deeper mechanism hidden behind the curtain. There are no tiny gears or hidden variables. There is only the math and the terrifyingly beautiful fact that the universe does not make up its mind until it is forced to. This leaves us with a sense of philosophical awe that no classical model could ever provide. We live in a reality that is fundamentally open-ended. It is a reality that exists in a state of multiplicity until the very moment of interaction. When you watch an electron, you are not a passive observer of a pre-existing world. You are a participant in the process of happening. You are the point where the infinite paths of the past converge into the single, solid line of the present. The electron isn't strange because it's small. It's strange because it's honest. It shows us the world as it truly is, a shimmering field of potential, waiting for someone or something to look. Feynman was right. The universe isn't just stranger than we imagine. It is stranger than we can imagine. And yet, here we are, part of the very mystery we are trying to solve.